Hey guys, I posted the answers for the test today, so you should have those to look at. I hope you enjoyed your fourth quarter quiz. I enjoyed reading all your answers. It really made me feel connected to you, and I'm glad most of you are doing good and you're doing something kind of productive. Um, when I put 11 days, it means actually 11 days of school, not counting the Wednesdays. All right, so let's go over chapter 13. Make sure that you are reading the book as we go through. You should have done that for homework tonight. We're going to start on section 1. We've got new formulas. All right, so pressure. It's the result of a force distributed over an area. So the formula is pressure equals force over area. Pressure is a P, force is an F, and then area. So remember, force is newtons. Area is, you get area by length times width. So it would be, in our case, meters squared. And then pressure is measured in a Pascal. That's the SI unit. However, most of the time we're going to use kilopascals because the pressure is so small, like it's a small unit, so they always have to use kilopascals. And remember, a kilopascal is equal to 1,000 pascals. So it's just like everything else. Kilometer, any of those. I can't think of anything else that's a kilo right now. But besides a kilometer, I don't know. So pressure in fluids. A fluid is a substance that assumes the shape of its container. So remember, both liquids and gases are considered fluids. Like when we talked about air resistance, it's deals with anything that is a fluid. So liquids and gases. Air pressure increases as depth increases. So I'm sorry, the water pressure. Sorry. So the farther you go down, like in a pool or something, the as you go deeper, the water pressure is increasing on you. You feel that with your ears and stuff like that. The pressure in a fluid at any given depth is constant, and it is exerted equally in all directions. What this means is that if you go like a meter underwater, okay? If you're in the ocean or if you're in a river or if you're in a pool, doesn't matter what the size of the body of water is. If you're a foot under or a meter under or whatever, the pressure is the same at that depth. Okay, so it doesn't matter the body of water. So a foot underwater in a bathtub, a pool, a river, an ocean, whatever, is all going to have the same pressure. And it's exerted equally. So you feel it on top of you, underneath you, on the sides of you, whatever. So for a fluid that is not moving, depth and type of fluid are two factors that determine the pressure of a fluid. So the depth would definitely determine the pressure of the fluid exerting on whatever the object is, you or a boat, or like not a boat, a ball under the water or whatever, but also the type of fluid. Salt water versus fresh water. Salt water has more density, less density, it's less dense than fresh water. So that kind of, if you had Jello versus water, Jello would have a greater pressure. Air pressure in atmosphere. The weight of the Earth's atmosphere exerts a pressure of about 101 kilopascals at sea level. You are going to need to know that number right there. The weight of the Earth's atmosphere exerts a pressure of about 101 kilopascals at sea level. Air pressure decreases as the altitude increases. So as you go higher up, like in an airplane, the air pressure decreases. Like a hot air balloon, as it goes higher up, the air pressure decreases. Okay? So I guess that's it. Bye.